You're listening to the Cyberwire Network, powered by N2K.
Around every entry point and every clever attacker, Vectra sees the attacks others can't. How? Vectra has AI on it. Vectra's AI attack signal intelligence tells security teams where to focus, what matters. It wades through thousands of individual threat events so you don't have to. Attackers infiltrating your network? Vectra has AI on it. Attackers compromising your identities? Vectra has AI on it. Vectra AI, the integrated signal powering your XDR. Visit vectra.ai/showme to learn more. That's vectra.ai/showme to learn more. Hello, everyone, and welcome to the CyberWire's Research Saturday. I'm Dave Bittner, and this is our weekly conversation with researchers and analysts tracking down the threats and vulnerabilities, solving some of the hard problems, and protecting ourselves in a rapidly evolving cyberspace. Thanks for joining us.
Over the past year, we've seen the explosion of AI and LLM systems, and there's this misconception that defending LLM-based applications is super difficult because the complexity of LLMs and the rapid pace of AI advancement. So you can't defend something that's constantly changing. And we kind of wanted to dig into that and, kind of bust that myth.
That's Mick Baccio, Global Security Advisor for Splunk Surge. The research we're discussing today is titled LLM Security, Splunk and OWASP Top 10 for LLM-based applications.
And we did that using OWASP, the Top 10, the Open Worldwide Application Security Project. And if you're old enough to remember that off the top of your head, be sure to take your vitamins today.
So you're a better man than I. Well, for folks who may not be familiar with OWASP and its utility in putting it up against some of these LLM potential vulnerabilities, can you kind of lay that out for us?
Sure. Well, OWASP is a foundation. I want to say it was started 2001, around late 2001, I want to say. And basically, it's kind of those principles that we develop and build systems around, those best practices that we talk about in the industry kind of are codified there. So what we did was leverage the Splunk's OTel connector, and OWASP for LLMs is kind of one of the things we focused on. Out of the top 10 they have, we focused on 5, and we kind of came up with the best detections we could think of to help cybersecurity practitioners out there. So when you think of what those best practices are from defending LLM systems, OWASP is the body that would kind of codify that for a net defender. And so what we did was take those suggestions and come up with detections.
So what was the methodology here? How specifically did you interact with the various LLMs that you tested?
So we developed our own LLM, right? So that way we weren't attacking anyone's property or IP or a product in general. We want to do that in-house as part of a research network. So we deployed our own LLM models in Splunk's OTel connector, the Open Telemetry Connector, and tested our detection capabilities. And through those LLMs, we developed the best practices for 5 of the top 10 LLMs, like I mentioned. We started off with prompt injection, insecure output handling, the model denial of service, sensitive information disclosure, and LLM 10 model theft. And like I said, the detections we came up with were based on the telemetry we collected using OTel and the responses that we got from the LLM that we were testing on.
Well, given that it's a relatively short list here, how about we go through them one at a time and you can give us a little overview of what exactly you found? Shall we start with prompt injection?
Sure. So prompt injection, what we're talking about doing is manipulating a large language model through crafty inputs, causing those unintended actions by the LLMs. We're talking about direct injections that overwrite system prompts, while indirect ones manipulate inputs from external sources. So it's the same thing we preach when we talk about sanitizing inputs and outputs. Some of the detections we crafted were around that.
And so is that the key here to protecting yourself, is sanitizing those inputs?
I believe it is. Well, it's one of the keys. How about that?
Mm.
I kind of think when you talk about the top 10 principles, and we'll go through all of these, it's that concept of do the basics right. Eat your cyber vegetables is something my teammates tell me to stop saying all the time, but I can keep going back to it. It's you're doing the basic things right. The principles that the OWASP top 10 for LLMs are pretty similar to other top 10 principles you'll see according to other systems. And the reason for that is because it's essentially the same principles we need to do correctly, those foundational things. When we talk about new systems, new tools we're implementing, this is what we mean when do the basics right and keep doing those things. And it is difficult. It is. But doing those is how we build that base security.
Well, let's move on to the next one here, which is insecure output handling.
Sure. So when we talk about insecure output handling, Dave, the vulnerability occurs when an LLM output is accepted without scrutiny, exposing backend systems, right? So we talk about things like cross-site scripting, cross-site request forgeries, SSRF, even remote code execution or privilege escalation can be caused by output handling, any insecurities inside that. So it's one of those things, again, critical when you're building out LLM systems using LLM-based applications as a net defender.
Can you give us a little insight here, a specific example of how this could play out?
I think some of the examples we had were there was an LLM system that the output, a user had tricked it into giving a card a discounted price or paying a specific fare for an airline. And it's
Mm.
those insecure outputs that kind of lead to a lack of or degradation in trust and reliance on those systems.
We'll be right back. Quick question. Do your end users always, and I mean always without exception, work on company-owned devices and IT-approved apps? I didn't think so. So my next question is, how do you keep your company's data safe when it's sitting on all those unmanaged apps and devices? 1Password has an answer to this question: extended access management. 1Password Extended Access Management helps you secure every sign-in for every app on every device because it solves the problems traditional IAM and MDM can't touch. And it's now available to companies with Okta and Microsoft Entra and in beta for Google Workspace customers. Check it out at onepassword.com/cyberwire. That's onepassword.com/cyberwire. The IT world used to be simpler. You only had to secure and manage environments that you controlled. Then came new technologies and new ways to work. Now, employees, apps, and networks are everywhere. This means poor visibility, security gaps, and added risk. That's why Cloudflare created the first-ever connectivity cloud. Visit cloudflare.com to protect your business everywhere you do business. I remember a few months ago famously seeing one where someone was in a chat with a local car dealer and somehow talked it into selling him a new Chevy truck for $5 or something like that.
Right. And it goes back to that principle, it's a machine that doesn't make a decision. So a machine can't be responsible. So it's back to you, to ensure that the safety and security of those systems is there before you get a result like that.
Right. Well, the next one is model denial of service. What can you tell us about that one?
So denial of service is pretty, I guess kind of a universal concept when
Mm.
attackers cause resource heavy operations on LLMs. And on LLMs, we're not talking about, hitting a website over and over again or hitting an internet service provider. We're talking about levels of something called compute, those computational cycles in the back end that kind of make all of the trains go when it comes to LLMs and generative AI. Now, an attacker is going to cause resource heavy operations, kind of leading to degradation of service. And that vulnerability is going to be magnified because LLMs are so resource intensive. And the unpredictability of user inputs will kind of, exacerbate that situation. So it's important to kind of safeguard against those denial of service attempts like you would a website or any kind of infrastructure that you have.
I love in the research here, the example you used was the prompt you gave. It says, say cheese over and over until you can't say it anymore. I mean, it's funny and it's clever, but it really is a simple example of how you're basically creating an endless loop.
Exactly. Exactly. I think it's akin to the if you are fork bomb years old, it's something that's just going to hog all the resources to any system, and there's not really a way to quite turn that off unless you put in a limit.
Right, right. Well, the next one is sensitive information disclosure. What do we need to know about that?
So when you talk about sensitive information disclosure, this is one of the critical things the more we leverage LLM tools as part of our daily job. You may inadvertently reveal confidential data in those responses, leading to unauthorized data access, privacy violations, security breaches. When you think about you are putting a lot of your organization's data inside an LLM, what is the proprietary value of that data you're putting? And should that data be accessible to anyone that has access to that LLM application? So I think that's where it becomes extremely critical to implement data sanitization and strict user policies to kind of mitigate that so that whatever data you're putting into a system is only allowed to be accessed by certain people with certain roles.
Yeah, the example you used, so you were using an SDK from Microsoft called Presidio, which looks for personally identifiable information. So is the notion here that you use a tool like this on the head end to make sure that people aren't inadvertently allowing this information to get to the LLM?
And conversely to get back to the user.
I see.
So even incidental patterns that you might search for when you think of things, not surreptitiously or directly, but inadvertently, IDs might match, an account ID might match a regular expression that matches a credit card or a passport number or a
Hmm.
social security number. And it's those regular expressions that might inadvertently return data that is what we consider PII. So it's important to set up an alert for those things and calling to a back end. It's not an LLM issue, but it's again the design of your system should be able to identify which user access what data. So that's where audit trails become super important. So in the event that those sanitizations aren't 100%, you have that audit trail.
No, that's interesting. I'm thinking of an in-house LLM and someone asking it, give me all the information you have about our HR director Bob, and here's
And it
here's
goes
how
from
much
there.
Bob makes, and here's here's the last time Bob was sick, and all those kinds of things. There's if that data's in there intentionally or not, that's something you got to protect against.
Exactly. Exactly. The thing becomes more critical the more we have this reliance on these LLM systems.
Yeah. Well, the last one you cover here is model theft. What can you tell us about that?
Model theft is exactly what it sounds like. It's the unauthorized access, copying, or exfiltration of proprietary LLM models. And the impact from that is anywhere from absolutely nothing to catastrophic economic losses, competitive advantages being zeroed out, or potential access to sensitive information. And I think it's that model theft is something that we kind of need to figure out how to combat best, inferring the contents through repeated queries. Like I think this is very much, and I kind of harken back to that cyber veggies metaphor where you access audit log, or audit access to either the systems that contain the model data or rate limit requests, because extracting it through inference is pretty noisy. So, and I think that is one of the many approaches you can take. You'll need to know what data they're trying to extract in order to detect the attempts. It kind of goes back to that concept, not through OWASP LLMs, but OWASP in general, where knowing your environment well enough to defend it.
Are there any sort of broad general take-homes that you want to offer to our listeners here from the research that you all did? What are the words of wisdom you like to share?
Wow, it is tough, and it's getting tougher out there. I think security practitioners across every industry need to ensure that they're putting the right practices in place to secure the LLMs being deployed in their environments. And I think that business owners and executives would take heed to listen to the same advice. Where many people are worried where it's too complicated, I think the research that the team has put out kind of show that you can defend using established principles we've known about for quite some time, principles that have been in place for quite some time, making it easier to improve LLM security moving forward. I think most importantly, don't confuse efficiency for efficacy. It is doing something quickly is not doing something effectively or doing something right over and over. And I think that's where we really, really need to be careful when leveraging LLM systems, because they do move so fast, and I predict they'll be moving faster.
Our thanks to Mick Baccio from Splunk for joining us. The research is titled LLM Security, Splunk and OWASP Top 10 for LLM-Based Applications. We'll have a link in the show notes. We'd love to know what you think of this podcast. Your feedback ensures we deliver the insights that keep you a step ahead in the rapidly changing world of cybersecurity. If you like our show, please share a rating and review in your favorite podcast app. Please also fill out the survey in the show notes or send an email to cyberwire@n2k.com. We're privileged that N2K's Cyberwire is part of the daily routine of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K makes it easy for companies to optimize your biggest investment, your people. We make you smarter about your teams while making your teams smarter. Learn how at n2k.com. This episode was produced by Liz Stokes. We're mixed by Elliot Peltzman and Trey Hester. Our executive producer is Jennifer Iben. Our executive editor is Brandon Karpf. Simone Petrella is our president. Peter Kilpie is our publisher. And I'm Dave Bittner. Thanks for listening. We'll see you back here next time.